Morning. My name is M. NARASIMHARAO, lecturer in physics. Today, I am explaining one numerical from system of particles and rotational motion. A thin rod of length L and mass M is bent at the midpoint into two halves, so that angle between the two halves is 90 degrees. The moment of inertia of this bent rod about an axis passing through the bending point and perpendicular to the plane defined by the two halves of the rod is, there is one uniform rod. Its length is L, its mass is capital M. It is bent exactly at the midpoint such that two halves are making 90 degrees between them. Now, an axis is passing through the, now, please listen here. This axis is passing through the midpoint of the rod. This axis is passing through the bent point such that plane of the two halves are perpendicular to the axis of rotation. Suppose this system is rotating about this axis. What is the moment of inertia of two halves about this perpendicular axis? Consider one rod. Its length is L. This rod is having some mass. Now, exactly at the midpoint, rod is bent into two halves such that two halves are making 90 degrees. Now, an axis is passing through the center of mass of the rod. An axis is passing through the bent point, nothing but middle point. Suppose this, now they told, plane of these two halves are perpendicular to axis of rotation, like this. I am the axis of rotation. Now this is one half of the rod, it is another half of the rod. If the two halves are rotating about this axis of rotation, what is the moment of inertia of the rod? Now please listen here. Total length is L. This rod is bent in the middle. Its meaning is this is the half of the length L by 2. It is the half of the length L by 2. Now, this total mass of the rod is capital M. This is the half of the rod. Its mass is M by 2. It is the half of the rod. Its mass is M by 2. Angle between the two half rods is, it is one half rod, it is one half rod. Angle between these two rods is 90 degrees. An axis is passing through the two halves of the rod, and this plane of this rod is perpendicular to axis of rotation. Now these rods are rotating. Now this is one rod bending in the middle. It is a half rod, it is a half rod. This system is rotating about this axis. What is the moment of inertia? Now please listen. Now this rod is the, I am taking one part. It is the one part. I am talking about this half rod. Now please, axis is passing through the one end of the rod. Now this length of the rod is L by 2. Mass of this rod is M by 2. The formula for moment of inertia when axis is passing through one end of the rod and plane of the rod is perpendicular to x of rotation, its moment of inertia I am taking as I1, that is equal to I1 is equal to mass into length square by 3. This is the standard formula. I1 is equal to mass of this half rod m by 2, length of this half rod, L by 2, length means L by 2, square I am writing square into 1 by 3, into 1 by 3. I1 is equals to m by 2 L square by 2 square means 4 into 1 by 3. That is equal to m L square into 1 L square by 2 4 ja 8, 8 3 ja 24. This is the moment of inertia of this half rod about an axis passing through one end point and the plane of the rod is perpendicular to x of rotation. Similarly, for this rod, this is the half of the rod, its length L by 2, its mass m by 2, axis is passing through the one end of this rod. Now please listen here. Now I am talking, this is the axis of rotation. Now this is the one rod, this is the one rod. This is the axis of rotation. It is the axis of rotation. It's a moment of inertia of this rod about an axis passing through its one end point and perpendicular to the plane of the rod. If this rod is rotating about this axis which is passing through one end point, moment of inertia of the rod, its length is L by 2, its mass is m by 2. Moment of inertia of the rod is equal to I2 is equal to m L square by 24. This rod length is same. Mass of this rod same. This axis is passing through end point, this axis is passing through end point. Now same formula, same answer we are getting. Now, moment of inertia of this total system about an axis passing through its bent point and plane of this system is perpendicular to axis, then what is the total moment of inertia? Moment of inertia of this bent rod about this axis of rotation, and this axis of rotation is perpendicular to plane of this bent rod, and the plane of this bent rod is perpendicular to axis of rotation. Total moment of inertia of this half rod about this axis plus moment of inertia of this half rod about this axis. Nothing but total moment of inertia is equal to I1 plus I2. Moment of inertia is a scalar quantity. Moment of inertia is a scalar quantity. Total moment of inertia of this bent rod is I1 plus I2. I is equal to I1 please ml square by 24. ml square by 24. I2 means ml square by 24. Total moment of inertia of the rod is bent rod about this bent point is ml square by 24 plus ml square by 24. 2 ml square by 24. 2 ml square by 24. 2 1 ja 2 2 n ja. Moment of inertia of this system about this axis of rotation is ml square by 12. Thank you.